Hello everyone, Michael with you here, and welcome back to my Git tutorial. Now, I know what you're thinking, has it really been more than a year since my last video? Well, yes it has, and for that, I'm really sorry it took so long. But, I've been really busy. If you look at some of my videos that aren't related to Git, you'll see some of the stuff that I've been doing as part of a PhD, which I am supposed to finish in October, so not too long to go now. But anyway, welcome back, and what I'd like to do in the next couple of videos is get more in depth with the day-to-day use of Git. So in the first 3 episodes, which was a lot of videos, I went through the very most basic aspects of using Git. So what I'd like to do now in the next few videos, and hopefully they won't be a year apart, is to get a little more in depth with what the power that Git has to offer. So some housekeeping things. Firstly, you'll note the new videos are in HD. So I'm uploading 720p videos to YouTube. So hopefully you'll be able to read everything a lot more clearly than you had been in the past. Also, it gives me a bit more screen space to play with. Secondly, there's a longer time limit. YouTube has finally extended the length of videos that are allowed, and I think, as said in my account, I can actually have videos longer than 15 minutes now. So while I don't want to make these lessons take forever, it's good to know that they won't have to be broken up into as many pieces. And finally, and this is probably the fundamental change, I guess, with how I'm going to approach these videos, is github.com. Now, GitHub is a website dedicated to hosting Git repositories. And the cool thing about it is if you're dealing with open source code, it's completely free. So what I'm going to do here is basically create a repository that's publicly accessible, so anyone can download whatever I put in here and follow along with the tutorial. Now you won't be able to push to it. I don't know if there's a way to make it so anyone in the world can push changes to the repository, but at least pushing it down and seeing how we work with a dedicated server, I think it'll be a lot more useful than in the past I was basically running a virtual machine. So with that, let's get started. In this video, what I want to do is basically look at working with remotes in a bit more detail, but specifically the difference between fetch and rebase and a pull. Okay, one of the things I've noticed with people beginning with Git is they kind of confuse these two concepts. They think that pull is basically a shortcut for a fetch and rebase, but it doesn't work like that, and the implications can be really frustrating if you don't know what pull does exactly. You run into problems. So anyway, what we need to do is I'll create a new Git repository. So where am I? I'll cd into code, make directory, test repo. Doesn't really matter what I'm calling this, and git init. Okay, so we've created a new Git repository in this folder. So what I'm going to do now is, so if we type git status, you'll see here completely empty repository. Let's create a file real quickly and just add it to Git. So vim readme.txt. Okay, so I'll save that and close it. So there's the file. Let's add it to Git and commit. So remember, I have to go back way ages ago to try to remember what I actually said in the last few videos. So remember that when we use git add, we're adding contents to be committed. So that puts them in the staging area. So if I type git status now, we see that there's some changes to be committed and it's a new file. So let's commit. Oh, nano, interesting. Control X, yes, enter. Okay, let's change my editor. Alright, now I'll get Vim appearing instead of nano. Of course you can use any editor you're comfortable with. So now, we've got an initial readme with an initial repo with one file in it, which is fine. So now what I'm going to do is add a remote to this repository, And somewhere here is my repo that I've created. Where is it? Here we go. Git tutorial. Okay, so basically, because this is my repository, I have SSH access to it, which means I can push changes to it. Now, you guys won't be able to do that, but if you want to clone the repository and follow along yourself, you can clone it using this URL here. So if you clone from that, and I'll go through this in a minute, you'll be able to pull down this repository and play along at home. So anyway, GitHub's really good. It's going to tell me exactly what I need to do. And here it is. Git remote add. That's where we're adding the remote. So I'll copy and paste this. And that's added. So now I want to push this repository to the server. Now you'll note, it's worth mentioning that at the moment, this repository has absolutely nothing in it, not even a master branch. So when the first time I do a push, I'll need to tell it what branch I want to commit, which will be master. So hopefully this all works with my private keys set up. It's quite slow. Thinking about it at all? I should have tested this before I started. Okay, here it finally goes. Yes, I want to connect. Now, it shouldn't ask me for a password here because I've got a public key set up. And hooray, we've pushed the branch and it now exists on the server. So if I actually go over here and have a look at commits, you'll see now that already the web interface is caught up and here's the README file. And we can actually look at this. Here's what changed in the README file. That's the git diff, I guess, with that commit. So again, if you guys want to pull this down, you can either do it, if you go to this URL actually, github.com/michaelmarner/git tutorial, you'll be able to pull down this repo. So that's awesome. We've got the repository and we're ready to go. So what I'm going to do now is explain how a rebase works and how it relates to a pull. So imagine that we've got the server. Let me just pick a color that's a bit more useful. Purple will work. Okay. So what we have to do here is have server. I know some of you thought that maybe I should write a little bit less on the blackboard, but this is really important. Let's say we have developer 1. And then we have developer 2. So what I'm going to do is white circles means commits from developer 1 and magenta circles means commits from developer 0, developer 2. So suppose that developer 1 has done 2 commits and then he pushes to the server. So this is basically what I've just done. I committed some code and pushed it to the server. So now our master branch on developer 1 and the server are identical. So suppose now that developer 2 does a clone. So now developer 2's local checked out copy looks like this with the exact same commits. Now let's suppose that developer 2 does 2 of its own commits and I need another color. This is annoying. Oh, alright. Developer 1 also does 2 new commits. Okay, so they're the new ones. Let's suppose, so what happens here is really, it's almost a race to push to the server first. So let's suppose developer 2 pushed to the server first. So now, what we have is the server matching what developer 2 has, not what developer 1 has, even though developer 1 has already done some commits. So what's going to happen here is if developer 1 now tries to push changes to the server, it won't work. And the reason for this is to push changes to a branch, the histories have to be identical or have to be able to be resolved. So you'll see here, developer 1 can't push changes because it doesn't have the work that developer 2 has already pushed. So this is really important. So what a fetch and rebase does is basically unwinds, I wonder if, does this work? Oh, not quite how I wanted, but that's okay. When you do a rebase, it rewinds the work that you have done and then applies the changes that were on the server and then puts your changes back on top. So now developers 1 repository looks like this. And if we do a push, let's get rid of that. I should have made sure the eraser worked before I started. So now if we do a push, it'll work fine because the histories match up. So you can see, and we can continue. So let's simulate this now. What I'll do is create 2 terminals. And I'll shrink them down a bit. New terminal. Probably didn't need to shrink them down a bit. So I'll give this terminal a name, developer 1. And this one can be developer 2. This title is really for my benefit more so than yours. Okay, so let's change into a new directory. So what we are going to need to do now is clone this repository, because developer 1 already has a copy of it, so dev 2 will need to do a clone. So I'll just copy and paste this. So git clone that. Now again, this will take a little while to pull down because my network connection seems to be slow, but let's continue, and well, let's wait and see what happens. That's really slow. Okay, and there we go. So now, if I type git log, oops, change into the right. Okay. Now if I type git log, you can see that I've got the original commit that developer 1 has done. So what I might do is here, change my developer name. Git config -- project user.name is dev2. So what this has done, okay, so in my global git config, I have a username which is Michael Marner. So if I type git log, you can see that Michael Marner has done this commit. So what I've done here is told Git that just for this project, make my username dev2. So now let's make a change. Vim readme.txt. Let's add a new line. Developer 2 was here. And close. Git status. Okay, so let's commit this file. Git commit -a. Oh, I need to export my editor again. Changes to readme. Control X, save, enter. So now if I type git log, you can see here that developer 2 has made a change here. So everything's working as it should. So let's do one more commit. Let's add a new file. Okay. All right. So now we've got a couple of commits that developer 2 did and the initial commit that developer 1 did. So now let's actually do this example. So let's get developer 2's changes up onto the server. So what we'll do is simply type git push origin. we don't need to explicitly say master here because both the remote and the local repository has an origin branch. So if I just, a master branch. So if I just push now, okay, now that's committed. Now what will happen? Well, if we look over here, if I just refresh this, is this going to do what I thought it does? No, that just shows that initial commit. History, here we go. Here's the commit history on GitHub. So you can see here that unfortunately GitHub isn't maintaining the log exactly. So it's put my GitHub username here, even though in the Git log it has developer 2 and Michael Marner. So let's not worry too much about that. Anyway, let's get developer 1 to make a change. So let's edit the README file. What did I call it? Ah, lowercase. Okay, so we've just made a simple change, and we'll commit -a to commit all our changes. Updates from dev1. Alright, so now developer 1 wants to push his changes to the server, obviously. So if we type git push origin, you can see here that it didn't work. Rejected. We couldn't push master to the remote's master branch because it's not a fast forward. Oh, okay. This didn't work. What does that mean? If we, unfortunately the error is not particularly obvious, but what it means is that someone else, in our case dev2, has made changes to the server that we don't have. So what we need to do is fetch them. Yeah, git fetch origin. So now we've pulled down the changes from the remote that we didn't have. So now we need to apply them. And this is where things start to go wrong. What we're going to do is the correct way first, and then I'll explain what Git Pull does in a minute. So let's git rebase origin / master. So we're rebasing our local master branch with the origins master branch. Hit enter, and I should have tested this first. It didn't actually work. So it's applying the updates, and it has a merge conflict in README. So what this means is that we need to normally Git's pretty good, and it can automatically merge conflicts, but in this case it didn't work. Let's have a look in README. Okay. So you can see here that our head has this. Sorry, this is developer 2's changes, and this was ours. So what we need to do is combine them. Basically, what we wanted was this. So now let's save that. Now, I didn't actually want to look into merging conflicts till the next video, but as it turns out, we need to do them here. So what happens if we get a merge conflict is Git puts into the file both versions of the file where there were conflict, and we just get to edit the file to come up with the version that we want. Once we've done that, we need to add the changes. So git add readme.txt, but we don't do a commit. Instead, we just tell Git to continue the rebase. And now it's worked. So if we look in our log now, you can see here that the original file that dev1 did, then the 2 changes from dev2, and then our change. So what a rebase does is undo any changes that we've made locally, applies all the changes that were on the remote server, and then tries to put ours over the top. And normally it works pretty well, but in this case there was a merge conflict. So let's just try one more version. This time we'll get developer 2 to do a change, and we'll do it the other way around. So in this case, what I'll do is make sure we do one that won't possibly have a merge conflict by editing astf.txt. Okay, so now git commit -a. Alright, we've done the commit. we try to do a git push. Actually, let's not worry about that. Let's assume that dev2 is smart and it knows that, and they know to pull down changes from the server before they try to push. So git fetch origin. Oh, there were no changes. Developer 1 forgot to push. That's another common problem I see with Git with new people. You have to remember to push your changes to the server or else it doesn't work. Git push origin. Okay, so let's try the git fetch again. Okay, so we've got the changes from the server now. Let's do a rebase. Git rebase origin/master. Hit enter. And that time, our changes applied with no conflicts, which is fantastic. If we type git log, we'll see that if we look through our entire history, we have the original commit from dev1, the 2 changes from dev2, then the update from dev1, then our last change has been applied on top of that. So it rewound, applied the latest update from the server, and then put ours on top. That's the important thing about a rebase, is it undoes any local commits that we've done, applies the server's commits, and then tries to apply our new ones over the top. Okay, so that's git fetch and git rebase. Now, git pull does something completely different. So if we let's try to simplify things a bit. We'll just have dev1 now. So 4 commits that both the server and dev1 has, and then developer 2 does 2 commits and pushes them to the server. Then let's find one more color. Green will work. Developer 1 does 2 commits of their own. Now, remember that if we do a fetch and a rebase, these 2 commits get undone, these magenta ones will get applied, and then the green ones go on the top of that, and then we can push with no problem. The problem is if a lot of people, and it's kind of people coming from Subversion to be honest, will do a git pull. Now what a git pull does is instead of undoing our local changes and then applying the remotes, it tries to apply the remotes on top of our already changed files, like that. So now developer 1 has this local repository which looks like this, and when he tries to push, it won't work because the order of these, oops, I wanted white. The order of these is around the wrong way. So we can't push the, we can't push the green changes on top. Git will complain. That will not work, okay? And it can actually be a bit of a pain to fix. So let's do a simple example now to see what this looks like in practice. So the way we're going to do this is get developer 1 to make some changes. What can we do? Let's just edit readme. Not a very meaningful commit message, I know. Git push origin. Okay, now that that's pushed, we're going to get developer 2 to make a change of their own. So it's not, so developer 1 edited readme. Let's get developer 2 to edit ASDF. Okay, we'll commit this. Oops, tell I'm used to Vim. Okay, so we've done a commit. Now what we're going to do is a git pull. Now what this will do is it will fetch any changes that are on the server that we don't have, and then it will try to apply them on top of our local commits. So git pull. And we wait. Come on. Okay, that time it worked. Wow. So if we read, actually that should have worked. So if we read the log now, so you can see here that we have developers 2 changes and then developer 1's changes, and it shows up in the commit log a bit weird. It turns up like a merge. So the problem and this will give us an idea of when pull is useful. I don't mean to say that pull is a bad thing and we shouldn't do it. It's just important to know how it works. So now we need to push developer 2's changes to the server. So git push origin. And I'll let this one wait. I have been pausing the video in between commits because the network really does seem to be slow, but this one's kind of important. When it's ready. GitHub, if you're watching, could you make my SSH commits go really faster? Oh, that actually worked. Oh well, must be because we didn't break anything in the same file. That really is kind of annoying. I wanted to demonstrate an important lesson. Okay, so obviously Git's pretty smart and it's managed to figure out these changes and applied itself. However, on a more complicated project, we don't want this to happen. So it's always important when you're working on the same branch, in our case master, it's important to make sure you do a fetch and a rebase and fix the merge any rebase conflicts like that rather than doing a git pull, because often you'll find that in this case it worked, but a lot of the times it won't, especially if multiple developers are editing the same file. It's a real pain to debug. However, pull can be a really useful tool when we're working with branches, and branches is exactly what I'm going to look at in the next video. So with that, unfortunately my ultimate example demonstration didn't work quite how I expected. One of the problems with doing this off the top of my head without too much planning. So remember, just to summarize, fetch and rebase if it's on the same branch. And pull between branches. Now, I know some Git experts will complain at this because it's not always necessarily true. However, if you're just getting started with Git, it'll save you a lot of headaches. It's a lot easier to fix the code that you wrote after someone else has made changes before you than it is to try and fix someone else's code that you may not have ever seen before. That's another thing worth considering. You have to remember that if there are merge conflicts, at one point you're going to have to edit your code or someone else's. And in my experience, it's a lot easier to do the rebase because the changes that you're trying to resolve are changes that you made rather than another developer. So with that, I'm sorry it took more than a year to get this next video, and I'm a little bit annoyed that my big example didn't work exactly how I wanted, but we've covered a lot in this video. We've looked at pull, we've looked at fetch and rebase, and we've looked at using GitHub, which I think is an awesome tool. So with that, that's going to wrap up this video. Thanks a lot.